Okay, next question. I haven't game planned this because I wanted you to hear my thinking. It's very important to hear my thinking going through this, just because there's a lot of things you can do. So number one, I'm going to keep that to the end. Cotangent can be converted into a fraction. Now this squared, I'm just going to show you what that means when we do it. Um, tan x is sine x over cos x. If this was tan squared x, it would be sine squared over cos squared. If this was tan cubed, it would be sine cubed over cos cubed. So for the cotangent and the tan, when you've got, actually for any of the reciprocals, when you've got this squared and you're converting it, the squared just goes with the answer parts, except for the trig ones. So this relationship is cosecant squared theta, that's 1 over sine squared theta. Like, the squared just goes with the trig piece, except for your Pythagorean. I think I called them the reciprocal earlier. It will. Not re-recording, not doing it. Okay. First, I want to write the question down here. 1 plus cot squared theta equals cosecant. This is actually how I'd set up all of my pages because I know how much work these can be. So I would put them in the middle, like this would be like 1A, and I would put that way over here, but then I'd put this in the middle because then on the left-hand side of the page, you're going to do some of the work, and on the right-hand side of the page, you're going to do some of the work. So I always put the questions right in the middle of the page. What do you want to do first? You can't talk to me. So I'm going to actually change our... I'm going to change our right-hand side because I'm not very comfortable working with the reciprocal ratios yet, and I'm a grade 11 who's just seeing this for the first time. So I'm going to change the right-hand side into something that I recognize, which is 1 over, so cosecant is 1 over sine. Because this is cosecant squared, it's going to be 1 over sine squared. So the right-hand side I'm changing to 1 over sine squared theta. Okay. Okay. So if I'm still looking at the right-hand side, I've got this business happening down here. And according to this, I could change the sine squared theta to a 1 minus cos squared theta, which is intriguing. And sometimes when you see things, you just want to change them because there's something you can change them into. But it's got to help you get to an answer. And this has a minus in it, and this side doesn't have a minus in it. So I'm a little hesitant to do this move, even though it is true. I don't know if it's going to help me get to an answer. So I'm going to hold on that one. I'm just going to leave it there and let you think about it and see that even though it is an option, we don't have to change it. And I'm going to move over to our left-hand side. So I'm going to leave the 1 because the 1 is money. I'm going to change the cotangent squared theta to the cos squared theta over sine squared theta. Ugh, I did it again, Megan. Cos squared theta over... Now, I don't hate that move. And the reason I don't hate that move is because all of a sudden I'm seeing this on the right-hand side and I've got it on the left-hand side. So I'm moving in the right direction. Keeping this as sine squared theta was the right move. Okay? It's not wrong to change it to that, but then you might not have known if you were on the right track. So students start doing these questions and they're like, I'm going to change everything at once, and then they don't know what to do. So you have to just go one thing at a time. Now, I'm going to stay on the left-hand side. I've got a 1 plus a fraction. The fraction is ugly as sin. That's fine. But my rules, what are my rules when I'm adding fractions? I have to create a common denominator. This 1 can be manipulated into any fraction that I want as long as the numerator is the same as the denominator. And I'm going to force it to be this fraction, which is going to be a sine squared theta over a sine squared theta. And the reason I'm forcing it to be that fraction is because this fraction already told me that my denominator has to be sine squared theta. It was the only thing I could change in the first, well, no, it wasn't. It was the thing I chose to change in the first step. And then I looked at it and said, okay, whole number plus a fraction, force this whole number to become a fraction where the denominators are the same. Okay, what are the rules when you are adding fractions and the denominators are the same? We just add the numerator. So I can't add this. It's just going to end up saying this because they're not like terms. But the denominator just stays as it is. I really like this. Now I've got an expression that's like almost there. I've got a denominator that says sine squared theta. Now I just need sine squared theta plus cos squared theta. I need to make that into a 1. Let's go back to our toolbox. Sine squared theta plus cos squared theta is a 1. Our last step is using the Pythagorean identity. We go, yes, I'm right. The numerator sine squared theta plus cos squared theta, the Pythagorean identity told me that that's 1, and that's over sine squared theta. My life is awesome. Left side equals right side. Quod erat demonstratum.